progress into probability. All right. So you are very familiar with the topic already. But then today we'll be looking at some of the complex parts, although we'll have to start from the foundation, but then we shall progress to the complex parts of the probability. So probability simply refers to the likelihood that an event will happen or the likelihood of an event occurring. So, so when there is probably you are trying to guess, you're guessing. We do say that most of the time that probably it will rain today. So you're not so sure, but maybe it will. So it's just the likelihood of an event occurring. Now, there are two possibilities in probability, two certainties. The first is when there is 100% certainty that an event cannot happen, then that probability is zero. When there is 100% certainty that an event cannot occur, then that probability is zero. So that's to say that impossibility would be zero. So impossibility equals zero. This shows that it is not possible. This is not as if you're guessing, you know that it is impossible. An example of such is today is today is Thursday. If someone asked, what is the probability that tomorrow is Sunday? You don't have to guess. You won't say, maybe tomorrow might be Sunday. You're not guessing. Here you are, 100% certain that it is impossible. Now, any probability where there is a certainty of impossibility, then that probability is equal to zero. Today is Thursday. What's the probability that tomorrow is Sunday? Impossible. Zero. All right, so that's just an example. Then there is the other certainty, that is when you have 100% possibility, 100% possibility. An example of such is today is Thursday, like I said earlier. What is the probability that tomorrow is Friday? What's the probability that tomorrow is Friday? You don't have to guess. You can't say there's no maybe there. Tomorrow must be Friday because today is Thursday. Tomorrow must be Friday. There is no time that you can skip Thursday to Saturday without getting to Friday. So since we are 100% certain that tomorrow must be Friday, asked what is the probability that tomorrow will be Friday, and we're 100% certain that since today is Thursday, then tomorrow must be Friday. That's probability where there is certainty of possibility is equal to 1. So when you have 100% certainty, then the probability is 1. So these are the two parts you must look at first. Very impossible, 0. 100% possible, 1. You're 100% sure. The probability is 1. And then the lowest you can get for a probability is 0. And the highest you can get for a probability is 1. That's the 100% certainty. You can't go if you're looking for a probability and you're having 1 point something as your answer, then you know that that result is wrong, because the highest you can get to in a probable question, a problem relating to probability, the highest should be one. That is 100% certainty. The lowest should be zero. That's 100% impossibility. And now the formula for probability would be so the probability would be required outcome, the required outcome over the possible outcome. Taking quick revision of what you the foundational part that is known already. So probability is given as the um, required outcome over the possible outcome. The possible outcome at the bottom refers to the total sum of all possibilities. Like for instance, you're told that a basket contains maybe 10 identical balls. That's 10 identical balls, the total number of balls. That's the possible outcome. That's to say, that fraction required over possible outcome. The total is what you should have at the bottom. So in probability, the total is what the total of the those individual events. That's what you should have at the bottom. So if you have a question in probability where the number at the top is now bigger than the number at the bottom, you know that you're wrong again. So the total number, that's the one at the bottom, the possible outcome, while the required outcome is a subset of the possible outcome. That's required outcome can be found within the possible outcome. So quickly, what you've known already, let's say an example, what you've known already, just a quick one, and we'll continue to delve into the complex part bit by bit. So let's say that a trolley contains 5 red and then let's say 13, 5 red and 13 blue identical balls. Identical balls. Okay, so if you have to pick out a ball from here, if you have to pick out a ball from here, what is the probability that the ball would be, let's say a red ball, for instance. Let me just use these, let me just write it here so it will be easy. Okay, a trolley contains 5 red and 13 blue identical balls. So the ball was randomly selected. What is the probability of picking, say one, a red ball, two, a blue ball, and three, a white ball? Okay, I think it's better this way. So I have the question here. It says that a trolley contains 5 red and 13 blue identical balls. Then a ball was randomly selected. What's the probability of picking a red ball, a blue ball, a white ball? So the first thing you do is you would need to know the possible outcome. And the possible outcome is gotten by adding the total number of balls, both blue and red, together. So the possible outcome here would be the possible outcome is equals to 5 plus 13, and this gives you 18. That's the possible outcome. Then you proceed to determine probability of picking a red ball. So here for number one, can say P of picking red. That means probability of picking red. What I just wrote there, this P here, P of red. That's P bracket red. It means probability of picking red. Here there are 5 red balls, and you have 5 over the total of 18 over 18. So this is the probability of picking a red ball. You can see that the 18 is the total. That's the possible outcome, the one at the bottom. So don't make the mistake of putting the bigger number at the top. Probability, the highest is 1, the lowest is 0, like we talked about. Do you guys understand this first part? It's just a revision of what you know, though. Do you understand that first question? Do you guys understand the first part we just did now? Okay, all right. So, so I'll leave you to take number two, melody. This is a revision of the parts you know. We've not gone into the complex part. So, melody, you take number two. What's the probability of having P of
I do know that.
picking a blue ball? So I was
13 over
asking
18.
13 over 18. Melody, is that you?
Yes, sir.
I thought you just said you don't understand. All right, so that's fine. So this is
Yes,
just
sir.
yeah, this is just a revision of what you've known. We've still not even started the complex parts yet, so don't expect to see these questions in your theory. You can't see this particular type that we're getting now in your theory questions. I doubt you will even see it in objective. You still won't see it in objective. These are just the foundational parts. Then what would be the probability of picking a white ball? Let's ask Efosa. What would be the probability of picking a white ball here? A white ball.
1/18.
Is what?
1/18.
1/18. Okay, did you join us from the onset of the class? Did you join us when we started the
No.
class?
No.
Oh, okay. All right. Okay. So, I that's wrong. So I wouldn't want to say the correct answer because I would want to ask someone else. So we'll come back to that though, why it is wrong. So Melody has answered. Efosa, um winner, Golden, have you been in the class or you're just joining? Okay. All right, Lucas, just take this question. So, what's the probability of picking a white ball?
I think it's zero over 18.
Okay, who answered this now?
Efosa.
Oh, Efosa. Okay, 0 over 18. That's just simply zero because why? Can you explain why? Why it's zero?
Because there is no white ball. There was not picked. The white ball was not picked.
Not that the white ball was not picked. That's not the actual reason. The first thing you said is the reason because there is no white ball in the trolley. So it's impossible to pick a white ball when there is no white ball there. Do you understand? Does everybody understand? Does everybody understand why that result is zero? Winner, you said you do not understand. Have you been in the class, winner? Winner, why don't you understand?
No, sir.
Have you been in the class?
How? No.
Oh, okay. So that's why. So, winner, I'll quickly ask you this question so that we can continue and go into the complex parts now. Winner, can you hear me?
Yes, sir.
Okay. What's today? Today is Thursday, is it?
Yes, sir.
Okay. Is it possible that tomorrow will be Monday?
No, sir.
Okay. It's okay. Do you have to guess? Do you have to say maybe before you be 100% sure that tomorrow can? Do you have to guess before you be sure that tomorrow cannot be Monday?
No, sir. I don't need to guess.
Okay. So if you are 100% sure that it is impossible that tomorrow will be Monday, that probability is zero. You are 100% sure that it can never happen. Do you understand?
No, sir.
Okay. Then look at this other situation. Today is still Thursday. If someone asks you what's the probability that tomorrow will be Friday, say you are 100% sure that tomorrow must be Friday. Can you hear me? Our network is
Yes,
always slow. So if you're 100% sure that tomorrow will be Friday, that probability is one. In essence, if you're 100% sure that something can never happen, the probability is zero. If you're 100% sure that something will definitely happen, 100% sure, that probability is one. So in this question, if you see this question, you will see that there is no white ball in the question. We only have red balls and blue balls. There is no white ball. That's why Fosa said the probability of picking a white is zero because we're 100% sure that we can never pick a white ball from that trolley because there is no white ball. Do you understand?
yes, sir. How do you got 18?
You have to add the total number of balls. There are five red balls and then there are 13 blue balls. The total is 18. 5 plus 13. That gives you your possible outcome. 5 red plus 13 blue. That's 18. So now when you're looking for probability of picking a red ball, you say 5. There are 5 red balls over the total of 18. Probability of picking a blue ball, there are 13 blue balls. You say 13 over the total of 18. Do you understand?
Yes, sir. Thank you,
And
sir.
then for the white, yes, and then for the white ball, it's impossible. There is no white ball in that trolley. So that's why Fosa said 0. All right. So now we'll proceed to um, something else. There is this simple way of getting a probability, the value for a probable question. See, if the probability of an event occurring is known, then the probability of that event not occurring is 1 minus probability that it will occur. Look at what I'm trying to say. If the probability of an event occurring is known, then the probability of that same event not occurring is 1 minus probability of occurring. So you have to take this down because it will help you a whole lot. But it's only in objective. You can't see it in theory. It's only in objective. That's where you can see it. So if the probability that something will happen, if you know it, then if you're asked what's the probability that the same thing will not happen, you just simply say 1 minus probability that it will happen. Look at an example. Example, probability that it will rain today. Probability that it will rain today is 3 over 9. The probability that rain will fall today is 3 over 9. That's what I wrote there. All those many sentences, that's what I wrote there mathematically. The probability that it will rain today is 3 over 9. That's what this P bracket rain equals 3 over 9. That's what it means. All right. Now, what is the probability? What is the probability that it will not rain? The probability that it will rain is 3 over 9. What is the probability that it will not rain? Look at what we just said. We said if the probability of an event occurring is known, then the probability of that same event not occurring is 1 minus the probability that it will occur. What you're simply doing is that if you look at this fraction, probability that it will rain, if you look at this fraction, you see that the total possible outcome is 9. That's the total possible outcome, 9. But you see that probability that it will rain is 3 over 9, meaning 3 chances over the total of 9. So probability that it will not rain automatically there will be a balance of 6 because probability that it will rain is 3, there are 3 chances there over the total of 9 at the bottom. Probability that it will not rain will now be the balance 6 chances over 9. That's the probability that it will not rain. And how do you get that? If it is a theory question, don't just write 6 over 9. You have to say 1 minus 3 over 9. But like I have told you, you can't find it in theory. Not this type. You can't see it in theory. It will be in objective. Okay. So probability that it will rain is 3 over 9. So probability that it will not rain, P not rain, is 1 minus 3 over 9. That's probability that it will not rain is 1 minus 3 over 9. Do you guys understand this part first? Lillian, do you understand what I just wrote? Golden, Efosa, Winner, do you understand this? Okay, so probability that it will not rain will be 1 minus probability that it will rain. That is when you do this fraction, when you try to solve the fraction, you see that you have 9 at the bottom, then 9 into the first part times the top, you have 9 minus 9 into 9 times the top, you have 3, and 9 minus 3 is 6 over 9. When you divide this, you have 2 over 3. So probability that it will not rain is 2 over 3 to the simplest form, or 6 over 9 when you've not simplified it. So like I've told you, if it's an objective question, you simply just look at the total at the bottom. The total is 9. And probability that it will rain is saying 3 over 9, meaning the rain took only 3 chances. So there will be a balance 6. Since the total is 9, there will be a balance 6. You just simply say 6 over 9. That's the other one. Divide completely and you have 2 over 3. Do you understand this?
Yes, sir.
Okay. All right. So now we'll go to the complex parts. I am heading into the complex part now. When I say complex, I don't mean it's difficult, just what you would be expecting. That's what I mean. So this is what you will be expecting in theory if it will come. So this is we're now introducing coin and dice now. We're introducing coin and dice. So let us say that question. Let us say um, a fake coin is tossed once. What is the probability of obtaining one, a head, two, a tail? Okay, so this is the question. A fair coin is tossed once. What is the probability of obtaining a head, a tail? You still won't see this in the theory. I'm only trying to introduce I'm trying to get into the parts that you see. This particular one, you won't see it, but we have entered the actual part that you'll be seeing relating to this. But this particular one, you won't see it. Now, if a fair coin is tossed once, what's the probability of obtaining a head and a tail? The a coin has two parts, as you that's if you guys have seen a coin. I don't know if yeah, you must have seen any maybe from anywhere. Yeah, so the coin has two parts. One part is the head, the other part is the tail. You see, on a coin, there's always one part. You see the head of the maybe the president or whatever, some important person in their history, the history of the country or something. Yeah. So that is the head. Then the other part is the tail. So your total possible outcome for a coin, only one coin. This is they said this coin was tossed once, coin only one. So if you have just one pen, one coin with you, the total possible outcome will be two because only head and tail that you have. So you see here, you have head and tail. So that makes your total possible outcome to be two, the total possible outcome. Now, if you have head and tail in the coin, and this question said the coin was tossed only once, what is the probability that you can have a head coin? It's just one head. That's all you have in the coin. So probability of having a head, if the coin is tossed only once, that probability there's only one head over the total of two, which is the possible outcome. We know the probability is always required outcome. It's here at the top. We said over the possible outcome. That's probability. Required outcome over possible outcome. So the possible outcome is the total number. That's the one at the bottom. I told you the bottom must always be bigger, while the required outcome will be a subset of the possible outcome. So here we say that since this coin was tossed only once, they only have head and tail. That's total two. Total of everything two. So probability that you have a head when you toss it once, there's only one head in one coin. So that probability of having a head is 1 over 2. Then probability number two, probability of having a tail. It's only one coin. So there is only one tail in one coin. One head, one tail. So probability of having a tail when you toss it once will still be probability of having a tail will still be the same 1 over 2 because you can only have one tail when you have the you know when you throw the coin. When you toss the coin rather, you can only have one tail. So 1 over 2. While if for the head, you can only have one head, 1 over 2 as well. Now look at this next question. Look at this question, this next question. This is the part where you should start expecting questions from your wife. Two fair coins. Fair. Two fair coins are tossed at once. Find the probability or determine the probability of obtaining one, let's say, of obtaining at, okay, of obtaining, let's say, two heads, two, two, at most, one head, three, at least, one head, four, find the probability of obtaining a head and a tail. 5, a head and a tail, in that order. If you look at number 4 and 5, you might think that they are the same. So they are not the same. So I'm dealing with just the head. You can use the knowledge of whatever I'll do for the head to determine whatever when you have a question relating to the tail. You can use the same knowledge that whatever I'll do for the head, you'll be able to use it for the tail so that we can do more. That's why I'm just taking this part that concerns the head. All right, so these two fair coins, now there are two coins. The fair there doesn't mean that the coins are yellow. The fair there doesn't mean that the coins are yellow. So the fair means that the coins are okay because maybe it's not as if maybe one coin has head, the other coin does not have head. Maybe the head has been cleaned off. Do you understand? So the fair there is referring to the both of them are normal coins. Each of them have head and tail. Head and tail. All right. So first off, you would have to draw an outcome table for this. It will help you a lot. You'll just be able to easily pick out your answers. So let's start. There are two coins, and these coins are fair. So if I'm drawing an outcome table, I would want to say this. Okay, I'll say for the first coin, I'll say head and tail. Let me use this one for first. First coin. This one for the second coin. So for the second coin, I still have head and tail. In the first coin has this question now differs from this first one. This one they said a fair coin was tossed once. A fair coin, only one coin was tossed once. But the second one, two fair coins are tossed at once. So there are two different coins. So in my table, I used, then you can see how I put the first coin at the top. The first coin will have head and tail. The second coin will have head and tail. Now, when you toss them, you toss them once. When you toss them up and then they fall back on your palm, then it is possible that the first coin will bring head, the second will bring head and head. Then it is also possible that the first one will bring tail, the second one will bring head, tail and head. Look at what I'm doing. Look at how I'm getting it. Here and here. Look at the arrow. Head and head. Then I get this. Then the second one, head and tail. You can say tail and head and tail and head. Anyone you like. If you prefer to use head and tail, it's okay. It's still the same result you have. So the second one, I came here and said, oh, the second one, I came here and said head and tail. That's how I got that answer there. So head and tail. Do you guys understand that? Okay. Then for this other one, now I'll say tail and head. So yeah, I'll say tail, head. While for the last one, I'll say tail and tail. So this is what we call an outcome table. This is the outcome table. So there are two coins. The first one has head and tail. The second one has head and tail. So when I toss them and I will later catch them when they fall back on my palm. It's possible that the first one will break, then it's possible that the first one will bring head, the second one will bring tail. That's head and tail, or tail and head, anyhow you want to write it. Then it's also possible, okay, then for the second one, maybe the first one will bring tail, second one will bring head, or then what am I doing? Please, I'm coming. I'm shifting the pattern. I'm using head, head, tail, head, head, tail. Then tail, tail. Alright. So the first one, head, head, tail. I'm taking this vertical one first. So you must follow a particular pattern. You can't miss them. Otherwise, one thing will appear twice. Follow a particular pattern. I'm taking this one at the vertical part, adding it to the one at the horizontal part at the top. So head, tail. Then tail. You have to follow one pattern. If you want to take the top, before the horizontal one and the vertical one, you have to follow that pattern until the end. You can't miss it. Otherwise, this number 5 will not be correct. If you missed it, you'll not be able to get the correct answer for number 5, but you can get the rest. All right, so now for your possible outcome, who can tell us our possible outcome? That's the total answers that we can have. Who can help us with that possible outcome? What's the possible outcome for these two coins? Remember, the possible outcome means the total answers that you can have. It's written here. It's just here. The first time one brought head, the other one brought head. One. One brought head, the other one brought tail. Two. One brought tail, the other one brought head. Three. One brought tail, the other one brought tail. Four. So you can have four different answers. Look at them. The head, tail, tail. Possible outcome. The possible outcome there is 4. The possible outcome is 4. Do you guys understand? Okay, so that's what you do to get the possible outcome. You'd have to count the possible outcome means the total answers that you expect to have. That's it. So 1, 2, 3, 4. Don't count the ordinary head and the ordinary tail. It is the answers. That one that has ordinary head and tail, that was before you threw it. So when you throw it, the answers you have, there are 4 things that can happen. Either they'll bring head, or the first one will bring head, second one tail, or tail head, or tail. So there are 4. So here we'll say possible outcome is equals to 4. Possible outcome equals to 4. That's the possible outcome. So this 4 is what we'll be having at the bottom of our fraction. First question, find the probability of obtaining 2 heads. Now look at your outcome table. How many times do you have 2 heads together? Melody, probability of number 1, probability of obtaining 2 heads.
One over four.
Okay, 1 over 4. So probability of obtaining 2 heads would be 1 over 4. So number 1, P of 2 heads 2 heads equals 1/4. Okay, then number 2, at most one head. Probability of obtaining at most one head. At most one head means from one head and below. That means highest of one head. You must not have more than one head. That's what at most means. You know, when you return from school, and then you're obviously hungry, and then for those of you who live with your parents, your guardian, and your guardian or your mom tells you, okay, go to the kitchen, go and serve yourself. Take at most one meat. What she just told you is that yes, you should take one meat. You shouldn't take more than one meat. So it's in the same you know we can relate it to what we're doing here, that at most one head means you shouldn't get more than one head. So what is the probability of having highest of one head? Who can help us with this? Probability of having highest of one head. Let's call someone so that it can be fast. Um, Lillian, probability of having at most one head, highest of one head. Okay, Lillian isn't responsive. Winner, what's the probability of having at most one head? Oh, no response. Lucas. All right.
Uh,
Okay, Lucas. Probability of having at most, number two, probability of having at most one head.
one over two.
At most one head, 1/2. How? Our total possible outcome is 4.
Maybe 2/4.
Okay, 2/4. So when you divided it, that's how you got 1/2.
Okay.
Okay, but that's still wrong. Probability of having at most one head is not two
It's 3
over
over 4.
is what?
It's 3 over 4.
Exactly 3/4. Lucas, probability of having at most one head is 3/4. So you guys listen. I know it looks like 2/4 because actually when you're looking at this, you'll be like, probability of having highest of one head. Okay, let me mark it out. So I'm marking it out with purple. I'm using purple to mark places where we have one head. So I have one head here. That place I marked purple because I have head and tail. There's one head there. Then this place will have tail and head. There's one head there too. So I think that's why Lucas said probability of having at most one head is 2/4 because it actually looks like, but then it is not. And this has nothing to do with mathematics itself. It has everything to do with English. Now I'll use the same illustration I used earlier. You return from school and your mom said, go serve yourself in the kitchen. Take at most one meat. So if you take one meat, Lucas, And the others listen. Oh, but Lucas, I need you to respond to me because it was you who answered the question.
Yeah, I'm
Lucas, can
hearing.
you hear me? Okay, I would need you to respond to me. So your mom said take at most one meat. At most one meat. Lucas, if you take more than one meat, say you're wrong.
Yes.
Okay. Lucas, if you take one meat, say you're correct.
Yes.
What if you choose not to take meat at all? Are you wrong?
No.
So you see, that makes it three. Where are the three? Head and tail, there's one head there. Tail and head, there's one head there. Then when you did not take any meat at all, that's this tail and tail that does not have head at all. There. You also have to count it because at most one head means from 1 to 0. From 1 at most means highest of 1 to 0. So that TT that there is no head there, you also have to count it. Do you understand?
Yes.
You guys, does everybody understand this? Does everybody understand that why it has to be like that? Does everybody understand why it's not 2/4 but 3/4? Do you understand the explanation I just gave? I'm actually asking the others, they're not responding.
Yes.
No, Lucas, not you, you've answered. Lillian, you do not understand. Winner, you do not understand. Okay, I'll go back. But do you understand the number one? Okay, all right. So I'll go back. Golden, Efosa, you listen. Okay, I think it was Efosa that answered. No, it wasn't Efosa. I made Melody. I didn't catch the person's voice actually. Okay, so for number one, probability of having two heads, we you can see that we have only once that we have heads twice. Then number two says probability of having at most one head. At most one head means highest. At most one head means highest one head. So if you look at this, you look at your outcome table, you're getting it from the outcome table. Don't count those ones that is ordinary head and ordinary tail. Those are the coins, the time you have not thrown it. When you throw it, the result you have, that's those ones that you are seeing two, head and tail and head, tail and tail. Those are the ones you're looking at, not the ordinary head and tail. Now, probability of having at most one head, meaning highest of one head. If you look at this now, you see that those ones I marked purple, you have only one head there, highest of one head. Head and tail, there's highest of one head there. Tail and head, there's highest of one head there. Then they said at most one head. So it actually looks like it is head and tail and head, where there is only one head there. We can't count head and head because there are two heads there. And they said at most one head. So we can't count head and head at all. Then we counted head and tail, there is one head there. We counted tail and head, there is one head there. So the answer now actually look like it's 2/4 because we counted 2/4. But it is not 2/4 because at most one head means from one head to 0. That's from one head and below. So you will also have to count that tail. That's tail and tail, that there's no head at all. You have to count it. That's why I was giving that illustration to Lucas when I said, when you return from school and your mom says, go and save yourself, but take at most one meat from the pot. So you can't take more than one meat. That's what she has told you. So she said, take at most one meat. So you can't take more than one meat. That's why we did not count that head and head because that one now be two meat. So we didn't count it. So I'm not saying look at head and tail. You took one meat there, at most one meat. There's one head there. So that's correct. Look at tail and head. You took one meat there because there is one head there. So that's correct. That's two now. Then what about when you did not take any meat at all from the pot? Your mom said take at most one meat. So if you take one, okay. What about when you don't take any meat at all? Maybe you just don't feel like eating meat, or probably have a toothache or something. What about you now decide not to take any meat at all? Did you disobey? Have you like offended your mom? But your mom said take at most one meat. Did you offend her? Have you done something wrong when you did not take any meat? No. The only time you offend her is when you now take more than the one meat that she told you. Because she said take at most one. So you see, when you take one, you are okay. When you decide not to take at all, that's also correct. That's why this tete where there is no head there, we are also counting it as a correct answer because at most one head means from one down to zero. So we counted one, head and tail, two, tail and head, there's one head there. Then tail and tail, there's no head there. That's is you did not take the meat, so that's zero. That makes it three. On that side, the probability of taking at most one head will be 3 over 4. Do you understand now? Okay, so that's why, all right, so that's why it's now 3 over 4. That probability of picking at most one head is now 3 over 4. So here we'll have number, oh, change it to black. Number 2, so number 2, now we'll have P at most one head equals 3 over 4. Okay, then we'll quickly go to number 3. We'll quickly go to number 3. Number 3 says that probability of obtaining at most, oh, sorry, at least one head. Number 3, you can see it there. Probability of obtaining at least one head. So at least one head means lowest of one head, meaning from one and above. At least one head, meaning from one and above. So lowest one head from one and above. So who will answer this for a probability of obtaining at least one head? That's from one head and above. Who will take this? Number 3. Efosa, would you take that? At least one head. No, Lucas, no, not you. You have answered 2 questions, I think. So Efosa, okay, Melody, all right. No, wasn't no Melody. No, Melody. No. It was you that answered. You and Lucas has answered. Efosa, can you hear me? Winner. Lillian, I think Lillian has answered one. Winner, not responsive. All right, Lillian, let's just get to you. Lillian, can you hear us? Okay, Lillian, number 3. At least one head. Look at the outcome table. At least one head. So what would be that probability? Oh, there's no response.
I sent a chat,
Okay.
sir.
No, just tell us because I can't open the chat. When I do now, it will. Don't worry. Just tell us. Probability of obtaining. Are you scared of? Are you scared of getting it wrong?
No, 3/4.
All right, 3/4. Probability of obtaining at least one head, meaning lowest of one head. So you can have from one and above. If we want to count that, we'll count that tail and head. There is one head there. Head and tail, there is one head there. That's two. Then head and head, we have to count it because he said at least one head, meaning we can have from one head and above. So you just take note of what this means. At least means from one and above. At least one from one and above. At most one means highest of one, meaning from one and below. So that's where English comes in. All right, so at least one head is same 3/4. We quickly do this so that we will be able to go. Number three, probability of at least one head. We're having same 3/4. Then next is probability of having a head and a tail. That's mixture of head and tail together. Mixture of head and tail together. It doesn't matter which one comes first. Mixture of head and tail together. So winner, you take this on. Probability of having a mixture of head and tail. That's probability of having obtaining head and tail. Winner, can you hear us? Ah, okay. Golden, Golden just joined, so I doubt if he'll be able to. Lillian, probability of Lillian, this question is just probability of obtaining a head and a tail. Look at the outcome table. Head and tail.
2/4.
Okay, 2/4. So the probability of having a head and tail is 2/4 because you see head, tail, and tail, head. That's mixture of head and tail together, 2/4 there. So number three, number four rather, a head and tail would be 2/4. If you divide this, that will be 1/2. Then lastly, probability of obtaining a head and a tail in that order. Now, this number 4 and 5 look alike, but they're not. For number 4, just the probability of obtaining a head and a tail. So anyhow you want to count it, so far as head and tail are together, it doesn't matter which one comes first. But you see this number 5, probability of obtaining a head and a tail in that order. It means that head first before tail. That's in that order. Head first before tail. So this type now, number 5, you can't count just anyone because head and tail are together. No, head and tail in that order, in that arrangement. So let's Lucas got one wrong. So let him take this one. Lucas, pressure obtaining a head and a tail in that order.
1/4.
Okay, 1/4. So if you want to follow the order head and tail, there is only one that comes in that order, head and tail. But if the question just says ordinarily probability of obtaining a head and a tail, you have to go and count those ones that have head and tail together. So no matter the arrangement, which one comes first. But that in that order is compelling you to make sure that head first before tail. And that's just 1/4. So for number 5, we'll have a probability to be 1 over 4 because there's only one head before tail. So this is where we're stopping for today. Please know that this is not a theory question. Objective, yes, possible, but this is not a theory question. The theory questions will most likely be coming from dice. When you toss two dice, one die has 6 sides. So when you toss two dice, that's what we'll be looking at next time. Um, Draw an outcome table for dice. Then another part, the multiplicative law of probability. That's the part where they say, selection with replacement and without replacement. That's the part you can see in theory. Selection without replacement. You won't see selection with replacement because it's too simple and straightforward. So it is always selection without replacement. Then also, what is it called? The dice. When you toss two dice together, and those are theory. But this particular one you've just done, everything you've done today, none would be those ones at the back. You will not see them at all. All these ones before now, you will not see them at all in the exam you're preparing for. It is only this is the only question that you might see, and it will be in objective. So you take note, and when we get to the parts that are compulsory theory questions, I'll let you know as well so that you can use the opportunity to start, you know, knowing what to expect. All right. So, do you guys have any question for this foundational part that we've done today? These are foundational parts. Any question on these parts so far? Okay, no question. All right, then. Then we can end the class here until next time. You guys take care of yourself. Bye for now.